let's start with like what is Kudzu and where did it come from? Where did it start before we get to how it applies to the Helium network?
Okay, so Kudzu comes from LoRaWAN background. We started the company about 4 years ago with Янnis. The idea was that we've seen LoRa development and how this technology goes around, and we've seen that it lacks a lot of information about how your network is actually operating. What LoRa has done is that it's very easy to install technology. It's completely, off the shelf. You just pick up some gateways, install them, and there you are. You have a network. But you also have a telecommunication network, which is not that easy to scale. Part of Kudzu is doing this type of analytics platform, which actually allows people who install LoRaWAN networks to have a much better view of how their network really operates on the field. The second part of Kudzu has to do with IoT design. We're developing an IoT platform which allows people to design their products on top of our IoT platform. And it's actually a multi-radio device which allows developers to make sure that your device can actually use any type of network that is available without really having to pre-configure all this information on your device. So this is actually the point. Usually we say that Kudzu looks like we're doing two completely different things. The idea is that if you are on a network which is monitored by Kudzu Analytics, then if you're using devices from Kudzu, then your devices know exactly what's the environment, what's the RF available, and then they will decide whether they should use, for example, Wi-Fi or LoRaWAN or satellite or any other available technology.
Okay, so two kind of separate things. There's the Kudzu devices, which are gateways and probably sensors. Maybe you guys are getting those for rack. Like it's basically its own little network. And then tell me how it ties into Helium specifically.
Yes, so what we decided to do with Янnis a few months ago is that we saw the development of Helium. We saw this type of disruption where actually the deployment of the network passes from network operators, so companies who know what they're doing, to random users who are just buying a couple of antennas and they want to see how much they're going to earn, where is the best place to place their antenna. So we did sit down and we thought about whether we are able to turn a completely business-to-business platform for people who know what they're doing into a product that will allow users to do this kind of stuff, such as test for witnesses or test for the reward scaling and other things that we're going to show in the demo. Okay. And apparently it did turn out very well. It turned out that it's not that big of a pivot for us. And it does stick to the idea of Kudzu that, if you are the network, since with Helium people are the network, they should be able to use tools, good quality and professional tools for deploying the network.
Okay. So I guess the first kind of big question for a Helium user is, let's say I just bought a hotspot, is how would I use Kudzu to optimize my earnings?
Yes, exactly. That's the idea. So we did try to, we are still actually trying, and we're evolving this type of tools because we want people to enter, Kudzu Analytics platform, and then without having too much knowledge of how to run simulations, because that's actually a difficult domain, they will be able to see, what's the best spots to place your hotspot. So what we're doing right now is the basic coverage analysis. So, if you place your antenna here, this is the coverage you're going to provide. This helps you, go around and see, for example, if there's a hill blocking you, if there are tall buildings blocking you and stuff like that. The second level of analysis has to do with if you place your antenna somewhere, how many witnesses you will probably have, which is what, for people who don't know the domain, it's what they call line of sight analysis, actually. Mm-hmm. And the third part is where Kudzu starts to calculate the reward scale that you're going to have if you put your hotspot here or there, or all this kind of stuff. This is the basic, the three types of basic analysis you can do in Kudzu.
Dig it. So you brought up an important point, which that this is just an analysis and simulation. It's not real world. So let's kind of start with that. Is where's the data coming from that you guys are using to assess either line of sight or the RF propagation models?
Perfect. Really nice question. Well, as for the RF propagation, this is pure math, right? It's a known technology, it's a known frequency, so you can just run the math and see how far your signal is going to get. The second part is that you need information about, the topography of the domain and, how high are the buildings, if there are hills around them, stuff like that. What we do in Kudzu is, first of all type of simulations run inside Kudzu, so there's no external service running the simulations. What this allowed us to do is that, first of all, you can click and drag around the map. You will see it on the demo, so you can have unlimited numbers of simulations, so you can literally just check around over the city. The second thing is that we are pulling information from different sources. We're pulling elevation information from SRTM files of NASA, Google Maps, wherever there are high quality data from national providers. Usually we use this data. The reason we do this is that we've seen that there are a lot of sources, and there's a big difference of whether you're looking the map from high above and you want to see, for example, a large region, or whether you are zooming in exactly on your spot, where, for example, with Kudzu in some places, you can even see structures on rooftops. So you can, literally just micromanage your gateway so that you can move it like half a meter, and then you have better coverage.
And just what if you have any other data that you can give us, for example, if you have already analyzed the topography in your area, we can also include them like in the map. Like this is like for additional, more advanced users, let's say, if for some reason we don't have coverage or things like this.
Okay, and are there places in the world where you have better and worse coverage? Do you feel like, say, Greece versus Germany or Germany versus the US, do you have kind of better quality data for one place or the other?
That's actually true because, as I said, we didn't start to be an RF analysis company, of course.
Sure.
So we are still gathering information from different sources. We do have some very enthusiastic users who like, hey, we have this type of data. Would you like to just put it on your server so that we have better quality? Indeed, if you zoom in Athens, for example, or actually in Greece region, you can get out up to, I think, 80 centimeters of analysis of resolution, which is amazingly interesting.
It's legit, yeah.
Sometimes it's difficult for users because, the higher quality data you have, the more precise the user must be. And sometimes, people are not very used to that.
So I guess that's a question that comes up for me is if there's going to be a difference in maybe not 80 centimeters of placement, but within a couple meters, does the Kudzu software allow me to say like, hey, within this area, within this 50-meter radius on top of a rooftop or 10-meter radius on top of a rooftop, is there a better place to put my antenna or not?
Actually, yes. Again, you will see it on the demo. One of the functionalities in the intervisibility, what we call intervisibility analysis, is that we do render the map. When you have like some hotspots on your city, we do render the map by how many hotspots you see in each pixel of the map. So right out before you deploy your hotspot, you can see, for example, that yes, this rooftop has, will probably have 20 witnesses, while this place is going to have like 18 or something.
Let me clarify this like one step further. So since we're running this analysis in your browser, we can drive the resolution to the maximum possible place, right? So even if the analysis, even if the elevation data we have for your area are a bit fuzzy, like with 1 meter accuracy, we can still interpolate with the neighbor places and can deliver you per pixel accuracy on your map. So you don't get any kind of fuzzy blobs. You actually get proper regions, like in high resolution regions in whatever place you go. So technically you can find out in like big resolution with big analysis, which is the place that you can put your gateway and you get the highest chances of getting your best like coverage. And yeah, so what Dimitris mentioned, that you exactly see this in the demo, we can show you a gradient that shows you which is the best place to put it so you can maximize the amount of visibility of other gateways that you have, that you're aware of, like and presently aware of.
Okay, but so just make sure I'm understanding, all of that stuff happens manually. Like I'd have to drag the hotspot and say, hey, check this corner of the roof and that corner of the roof and the next corner of the roof. Or can I just give it like, hey, take this 20
Wait for it.
to the best place.
You actually get a gradient that tells you what's the best place to do. So the analysis runs in real time throughout your screen, analyzes every pixel of your screen as the best possible location, and then gives you a gradient telling you here's the best place to put it and here's the worst place to put it. So you just like drag it in that area, and then it further runs like a visibility analysis from this spot to just like verify that that's indeed the place that you were looking for.
Okay,
So
do you guys want to take me through a demo on screen?
So this is the overview of what's going on right now in Kudzu. We do have about 1,500 different locations being checked on Kudzu. I will try to go to the location we have here in the island. It's a slightly, just for demonstration purposes, because since I'm on the admin account and you can see like thousands of gateways, I think it's going to be easier to go to a slightly smaller network there. There you are. So since you will be getting questions from users, I guess, what you can do in Kudzu the moment you sign up is that you can go there and add one, let's say, draft gateway. Assume, for example, that this is going to be installed like on a 4 meters mast, let's say. Most people are trying to put some large masts there. And there you are. You have your draft gateway on the list, and you can start actually moving it around. The rest of the positions you see is other possible locations that we have been trying, for example, to see if they fit nicely or not. I will actually keep this like that. I will open the rest of the Helium hotspots in a minute so that we have a slightly clearer view. What's happening here is that you can directly just click on the coverage analysis, and you start seeing what's the coverage of your location of your hotspot if you put it like 4 meters above the surface of the city. So you can just move it around. Let's say you have like 2 or 3 different places where you can install it, and then you can see your coverage. Now, as I said, usually coverage is we consider coverage to be slightly more a tool for more advanced users. You see, for example, here there's probably some kind of hills blocking you. But what is more interesting for users actually, before I go to that, there are some pro options in here, for people who actually usually know what they're doing. We do get a lot of questions about, should I change this or not? Yep. The answer usually is, if you don't know what you're doing, just leave it as it is. One of the things is that we are doing this for, we are calculating the Fresnel zone obstructions. If you disable the Fresnel zone, you get a much more optimistic view of your coverage. And to be honest, this is usually closer to reality in LoRaWAN networks, because LoRaWAN transmissions are very resilient to reflections, refractions, and stuff like that. While if you enable Fresnel zone, then the algorithm gets a little bit stricter. It's going to block your signal a lot more.
Okay, let's see, hang on a second. So 2 things. So Fresnel zone is basically if your hotspot is too close to a building, basically the waves don't get to propagate out that far, and so it blocks a lot more. So this is, when you're including the Fresnel zone, you're saying you're just going to get less transmissions, just to make that part clear.
Yes, a simple example of how Fresnel zone works is that if you have an antenna 10 meters high, and then you want to watch another antenna 10 meters high, again, you do have line of sight. Yep. But if there is something like 9 meters tall in between, it's not going to block your line of sight, but it will cause some reflections.
Yep.
So this is, a little bit stricter. I will go directly. I don't know, Yanis, did I interrupt you on something?
I'm just going to briefly say, do a very brief explanation for people that are listening us and have no idea what a Fresnel zone is. So technically, it's just like it's just like an ellipsoid zone from one antenna to the other antenna, which is like the longest it gets in the middle of your transmission. And then if the zone gets blocked by any kind of building, any kind of elevated surface or anything like this, causes reflections or like delays in the signal, which degrades the quality. Now, this algorithm, when you enable it, it kind of blacks out areas that are more than 35 or more than 30% blocking the Fresnel zone. You can actually, if I'm correct, I don't remember the numbers exactly right now. If it's blocked from 1 point onwards, it actually causes you such a bad reception that is no longer considered a viable link. So you get too much reflection, too much noise, so you shouldn't go there. But you can still have an optical line of sight in that areas. So it's given us as a warning. And everything else is just like slightly degrading the areas over the edges. But again, this is for advanced users, not really for everybody. But we include this because if you want to get like even better coverage, if you want to be sure that you're actually having the best possible reception, this is usually included by default in the analysis.
Sure.
So yes, this is the rendering in this coverage analysis is actually the signal attenuation, how strong your signal is going to be in the corresponding areas.
Cool.
I will move
hang on
on.
a second. One question. So are we going to get to where you can put in a different antenna? And then do you guys use like manufacturers' antenna, like their data sheet antenna patterns? Or is it just like, hey, this is kind of our standard 8 dBi, 9 dBi, 3 dBi?
We're going for standard omnidirectional antennas. We haven't added all these kind of features yet.
Right.
You can of course go there and change. I will do something extreme now just for demonstration purposes.
Yep.
You can go there and install a 180 dB antenna. Please don't do this. And you can see, for example, signal gets much better in a lot more regions. I will just go back to something like more realistic.
Since you're touching technical details, I'm just also gonna put like a small notification here. So the calculations are based on an average transmission power for sending and receiving, because in LoRa, normally you have different transmission power from the gateway and different transmission power from the device.
Yep.
This is doing an average between the two transmission powers, so it gives you like kind of a bidirectional best estimate. Of course, this can be adjusted by default. Again, this is for advanced people, like 80% of the cases or 90% of the cases already covered with the default values we already have.
That's why we hide these options usually.
Yeah.
Okay. So just if you're watching this, one of the important points here is that Helium was built for IoT gateways or hotspots to talk to really small sensors. What we're all earning off of with hotspots is basically gateways talking to gateways or hotspots talking to hotspots, gateway and hotspot. For the purpose of this conversation, the same thing. So it just means that in the long run, it's going to be more difficult for your hotspot to hear sensors, because the sensors usually have a smaller antenna and they have a smaller kind of ability to hear or to transmit their information, versus a gateway that's plugged into power that's got a nice big antenna. So it's just something to kind of think about and be aware of and know in LoRa world, like it's not just restricted to Helium.
Exactly. That's a very nice comment actually. And I'll just go through the platform, based on this type of comments. What we have been doing, and the basis of this tool actually is that D1 here, your draft, can also be a sensor. So you can go around, and see where you should install your sensor in order to have a different type of, to see the coverage there. You will see this better on the intervisibility analysis probably, but what you can do here on this level is that you can test the coverage in different levels. So right now by default, if you place an antenna here, you click on coverage analysis, we tell you what's the coverage is going to be 1 meter from ground. What people do in Helium, actually, they want to see, from one antenna to another now. So you want to see higher, and thus you get an even more optimistic view of the network. But again, if you're a network operator and you want your sensors or your customer sensors to be functioning correctly, you should go back there and render them up based on 1 meter high from the ground, so that you can see the actual coverage on the street.
Let's try not to confuse the users, just to clarify. So you can use a coverage analysis usually by default to find out what is the coverage for your sensors. The sensors are usually located on ground level. That's why we're estimating in about 1 meter from the ground. You usually don't use this view to actually find out the best placements for your gateways, but you usually use this view to find out how well my devices are covered. So which places should I put more gateways to have better coverage on my IoT devices? The next view, which the image is going to show you in a while, the intervisibility, actually accounts for the elevations of the gateways on both sides. So you don't need to care about what we just discussed right now. So this is right now if you want to just like try different planes and see, hey, let's say my sensors are not on the ground on 1 meter, they're actually on I don't know, on trees. So they're like on 4 meters on the ground. So you can say your plane at 4 meters, and that's how you can do your analysis. So yeah.
Cool.
I will jump to the next thing, which I think it's way more interesting for people who are using Helium and they want to see some where to deploy their antennas. We'll just focus on
sorry for interrupting. I just realized something that you just did, so I want to clarify what happened here. Once you unfocus your gateway, you actually get the overall aggregated coverage of your entire network. So if you can just go here and unfocus this gateway, you will see suddenly that the whole island gets covered by a single color. That's because if you're not analyzing one particular gateway, the system kind of gives you the coverage of your entire installation right now in this area. Just like
interesting. So when you guys are saying entire installation, you're saying this is representing the coverage from all of the blue markers on the map.
Exactly.
Yes. And I will show you later one of the things that is a core thing that Kudzu Analytics is doing apart from Helium. But let's give it some time. The second thing that Helium users can actually do in the platform, and I think this is where things start to get a little bit more interesting for them, is that if you focus on one of your gateways, so let's say that this is a possible location, you can go there and run the intervisibility analysis. Now the map, as we said earlier, is being rendered by, oh, sorry, that was I just clicked the back button.
Welcome, Ďmitrис.
There you are. We'll just take a moment to reset this.
Cool. So this island, as it comes in, it looks like a nice, challenging place to put Helium or LoRa gateways in general. There's plenty of mountains, but there's lots of ocean around, so you can really cover a fishing fleet if you're going to put a bunch of sensors out there. Probably really well, but probably pretty difficult to cover every inch of the island just because it looks so kind of topographically diverse.
It's very interesting that you say this. One of the key features in these regions is that there are some places, in nearby islands. These are usually, distances of 30 kilometers or something like that.
Sure.
There are places on, opposing islands that you can actually cover from, from one island to another, so that you don't have to go there and install some antennas. You can see, for example, the coverage from this point, which actually minimizes the cost of deploying networks and applications in this domain.
Cool.
It's a testbed that we have been using for quite a long time now for doing all this kind of development. Okay, so give me a moment to just turn on thing. I will just
Sure. So while you're doing that, Ďmitris,
this back button just ruined the demo.
Getting you, yeah. While you're doing that, so I'm just kind of thinking out, as we've got two very different use cases here. On the one hand, we've got people who are deploying Helium hotspots that are basically mostly concerned with how much HNT their hotspots can earn, and maybe if there's a big difference in a small distance of placement, so kind of on one side of their roof or another, or one side of their property or another. And then the other use cases for people who are actually using the network and who are really interested in whether or not their sensors can be picked up by the gateways. Now, eventually everything's going to go to figuring out if your sensors can pick up gateways. But for the next couple months, we're recording this August 2021, maybe by February 2022, I think we're going to be shifting over to really focusing on whether or not sensors can pass their data, because that's how fast the network's growing. And really that's how fast the network has to get used in order for it to be sustainable.
Exactly, and this is the merging of the two different worlds. As I said, we are coming from the network operator view, where people until recently they didn't care about how the witness from one antenna to the other. What they care is where should they put their antennas so that their customer applications is going to be functioning. So this is the basis of Kudzu Analytics, and we're just doing some changes to help Helium users do what they want.
Yeah,
so
that's actually.
That's
actually an interesting point, by the way. So what happens is that people right now are looking at the earnings of the Helium, but what they actually want to become practically, even if they don't realize that, they actually want to become network operators. Because by installing these Helium gateways, of course, one thing is that you're getting your earnings high, but at the other time, you're also becoming slowly a network operator. You're actually starting to manage your own fleet of devices. So you're actually right. We might now be interested into increasing our gains, but soon you would actually be interested into figuring out the best places to put so you can maximize your traffic, perhaps, or things like this.
Yep.
Yeah. So we're going now to the intervisibility analysis. Again, there are some hidden options there. Don't touch them unless you know what you're doing. Now, the rendering of the map has to do with how many hotspots you can see in each place. So, with a very quick view, you can see, for example, that blue regions is where you see one or two other hotspots, and the more you move towards the red regions, you will be getting much more witnesses. And you can actually see this. If I move this, for example, to the yellowish region there, you will see that these are the line of sight, the possible witnesses you're going to have. Which is, we think it's a very nice tool, because the moment you look on the city, you can directly figure out, like, hey, what are the best spots to install my hotspot now. If I go
Sorry
to
for interrupting again. Just to clarify something, because that came in as a question from some of the users. The colors you see here might be the same as we saw before with the radio coverts and decibels, but they're actually not the same thing. So we just use the same range for showing different things. Just note that this is not the decibels and the quality of reception now. It's actually count how many different gateways do you see.
Yeah, it's interesting. I saw that, and that became more clear when I saw the black lines, which I'm assuming are just a straight line from your hotspot to another hotspot that represents if there was a clear line of sight, you'd connect to that. So in this case, the green areas, how are you guys managing how many hotspots are in an area but that are not being seen? Or is it all that we're seeing here is that in the greener areas, you're more likely to see more hotspots that are actually online?
Yes, Yanis, would you like to go through those?
I didn't get the full question. Actually, your audio was a bit damaged.
Yes, your audio is a little bit, slightly lower now.
Muted.
Okay, I'll see if I can. I'll get more on the mic.
That's better.
Okay, so the question I'm asking here is, I'm trying to make sure I understand what I'm seeing, and I think I'm seeing with these the more kind of green it is, that the more hotspots I'm going to be able to see or to witness. But what my question is about is, how are you guys managing how many hotspots are in a given area? And I guess the percentage of hotspots that I'm going to see in a given area, because this doesn't seem to represent that there's like 10 hotspots in one area and one in another.
I'm just going to go here. So there is an issue here. Okay. You're actually right in that particular part. So that's why the scale on the map is a bit misleading. So we actually show you the total number of gateways participating in this analysis. And out of this total scale of gateways, you might actually see 10. You don't see all the 100, for example. That's why the scale is a bit biased. So this is one of the bugs, let's say, we get reported, and we're working on changing a bit the scale and the way we're actually doing local grouping. So it actually, what you see kind of makes more sense. But what happens behind the scenes is that for every pixel of the screen, we're actually doing a line of sight analysis, including RF analysis and including Frontal Zone obstruction. So we can do all this kind of analysis we saw before, directly from every point on map towards all the gateways you have available on view. And for how many, the more gateways find out that there is a coverage, we increase that number by 1 in this particular area. So for example, if you go to somewhere which is like yellow-green, your goal here is to actually go as red as you can. So for example, you find a region which is like yellowish, you're going to have the maximum number of gateways, because at that point, you're looking at the most number of gateways around the area. Exactly as the mirror is showing right now.
Okay, now can you use that in reverse to see, like, the more yellow an area is, I'd put my kind of proposed gateway placement there and then see if I popped up with any red? Or like, how would you use this if you just have one gateway and you're trying to find the single best place in this map? We can
actually use a map for that. So
let's do something. Sorry, because it gets a little bit bloated. I will isolate this and just toggle it off just for a moment, and just I will click on these to just show you the live hotspots. The green dots are live Helium hotspots. So the moment you, let's say you want to start off, these are the hotspots in your region, in your area, in your city or something, you can just go there. I will add another more, there's no problem. You can add your own hotspot there. And the moment you click on the intervisibility analysis, the map is being painted based on what we have been describing. So the closer you go to red, the more hotspots you're gonna be able to view. So it doesn't really matter where you placed your draft. The map is being rendered based on how many Helium hotspots are live, what's the topography of the region, and there you are. For example, there are some some red areas there. If you have a home there, or a friend who lives there, it's pretty possible that you can go there, install your hotspot, and there you are. You have the maximum witnesses.
I think I understood a bit of the confusion, so I want to clarify something. Let's say if this is, let me know if this is exactly what you're looking at, what you're actually saying. So the fact that you're dragging this marker doesn't really change the physics of the analysis. It doesn't change actually the analysis. You will notice that wherever you put the marker, the background color is always the same. That's because this analysis kind of gives you all the possible locations where you should put your gateway, and it grades every single point as for how many visibility gateways it has. What it changes every time you move it around is like the lines, actually telling you which one of the gateways that I found is the ones that I'm referring to, because remember that every pixel here is colored by the count of gateways that it's looking at. So you don't know in advance which ones are the ones that you're looking at. So by just moving your marker onto that area, it tells you which is the gateway that it accounted for when it painted that color, that pixel.
Perfect. So you can see, for example, there's a blue area there, but before you move your marker there, you don't know which hotspot you're going to be witnessing. If you do move your marker there, the rendering is still the same because there are like 16 live hotspots in the region, but this time you see a different line. If I move it to another blue area, for example, here, you will see the rendering is still the same. But there you are. We have a line to completely different. Oh, it was the same. Actually.
This happens to be the same one in this particular case. But
yeah. And so that, I mean, that seems to be explained to me that hotspot that is consistently witnessed is in kind of the one of the best places on the island, and we're seeing that represented by the yellow.
High.
Yep.
You also see that this area is pretty yellow, right? And has also beautiful red there. So you see the whole island from that point.
Another thing we wanted to allow people to do, because sometimes the network is going to be changing for the months to come. People are installing more and more hotspots. They're moving around because of reward scaling and stuff. So if you already have one of your hotspots deployed, or even if this is let's say this one hotspot is your friends or something like that, you can always just let me switch to gateways. You can always choose this one hotspot here, pop this one to draft, and there you are. Now it becomes a draft hotspot, so you can actually move it around and see where you should move your hotspot to get better location.
Got it. So with that draft hotspot, can you also simulate what happens when that, like let's say you have 3 hotspots and you want to put these 3 hotspots in the place where they're going to witness the whatever greatest coverage or most other hotspots, etc. Obviously, Helium doesn't want you putting them all in the same place, even though that might be the place where you witness the most. Is there a method by which you can say, hey, I've got this area to cover and I've got 3 hotspots, where can I put them to earn the most?
Are you referring to the reward scaling, actually?
I mean, so reward scaling definitely affects that, right? Is that if we look at this map and kind of based on the information so far, is if you had 3 hotspots and you didn't know anything about Helium, you'd say, well, I'd put all 3 basically where your pin is, where that kind of most red part of the map is, because then all 3 of them will see a bunch of other hotspots. But the problem with that is they'll get transmit reward scaled. And so you really want to spread out those 3 to the kind of probably 3 best spots. But maybe there's some other spot here that if you were to cover it with other hotspots that aren't in play, maybe you end up getting more rewards for that.
It could be, yes. So for example, you can, let's say that you have like these 2 different hotspots. I will actually open up one more. So we have like 3 as your example. There you are. So you have 3 hotspots to place. As we said, the rendering on the intervisibility analysis is always the same. So you can actually say like, okay, let's see if we can move our hotspots in these places. There you are.
Just be aware now. Now you're moving your gateways. By moving the gateways, the rendering is not the same. You're actually changing the gradient.
Yeah, so that makes sense. Cool. So you can see where there's no coverage. So I'm seeing on the east side of the island, there's nothing, but there's probably some mountains over there. So I might drop a couple hotspots over there and see if I can build coverage up over there and still connect back to the kind of mothership of the big city, the bigger city.
Yes, exactly. So you can actually, knowing the topography, there's a big hill here, which is actually blocking the signal. But of course, you can move one hotspot there. You'll see that it starts covering here, but the whole region here is blue. So you cannot really get a lot of rewards. You cannot get witnesses to the other side of the city. But again, as you said, started building up. Maybe if you come here, coverage is going to start flowing from one side of the hill to the other. Actually.
Yep. Looks like you got a main ridge coming down the center of that island.
Yeah. Actually, this is the case.
Yep. Okay.
Great. So I will connect this part of the conversation to the next type of analytics, which we also feel like it's very interesting for users. Let's open the reward scaling. I will just close the intervisibility to because there's a lot of information coming on the screen. If users, we see that when users get used to the type of analysis, then they usually have both reward scaling analysis and intervisibility on top of each other, so that they can find best reward scaling and most witnesses. Now there's no real problem right now in the, let's just try to ignore these ones, on the reward scaling in this region, but if you allow me, I will just go there and cause one issue so that you can see what's happening live, for example. There you are. You can see that reward scaling went down to 0.8. Now, what we do in Kudzu is that we don't really pull the reward scaling information from the blockchain, because this is usually, a slow process. A new hotspot needs to have some activity before this is, this is recorded to the blockchain. What we do is we completely calculate the reward scaling inside the platform. This allows you to be able to actually see if you're gonna affect the reward scaling by moving close to another hotspot before you deploy it. And we've seen in a lot of platforms that, they pick the information from the blockchain, so that you can see that this one is on reward scale 1, but you don't know what's going to happen the moment you go there and place another hotspot right next to it. And in this case, we are in reward scale 8. You cannot really see any difference, but if you jump...
Yeah, just add one more. You'll start getting it down.
Yes, that's for sure. But you can also see, these small differences there. So you can actually decide that this probably is not a very good location. If I move there, what's the case? 0.637 and stuff.
Hang on, did I miss something? So does it calculate the reward scale only for the hex res shown, or does it count the reward scale for that hotspot?
It calculates the reward scale in the region that you have on your viewport.
Let me jump in a bit here, because that's important to clarify a few things. The reward scale for a particular hotspot is actually calculated at res 12. That's the actual resolution point where your gateway is being created at. That's like the point. But the resolution, this point onwards, affecting the lower resolutions inside. So that's why if you want to check your actual gateway resolution, you need to check the res 12. But the more you actually want to, the more dense you get in other areas, the other areas are also affecting the actual scale inside there. That's why we allow here to be able to choose between what scale are you want to focus in. So if you start big, and then the closer you get, and you find out that, say, at some point, this actually starts getting diverged from 1, it means that this region needs your attention. So you can zoom in and just adjust that. Then you zoom in until you actually find the place which is causing your trouble on the resolution scale.
Interesting. So it's not calculating the resolution of that hotspot. It's calculating the transmit reward scale of that hotspot. It's calculating transmit reward scale of that specific resolution of hexagon. So at res, whatever you're at here, res 8. It's
in addition, right?
Yeah. If you go to res 4, you're going to see just a 1.
Yes,
Exactly.
if I go, for example, here to res 7, things are usually fine, perfect. You don't have a problem. But if you just start, going deeper in the resolution, that you can see that in
just to clarify something, if you click the gateway, you will still see the actual resolution scale of that particular gateway. So it shows you here as information, which is computed again, as we discussed on res 12. But you have the ability to actually select all the different components, let's say, that participate in this calculation, so you can debug it into the level you want to.
Interesting. Do you guys have a tool that will automatically show that and say, like, hey, you're getting scaled at res 7, so that you could look at the res 7 lines?
Actually, that's a nice feature. Okay. I never thought about it. Sure. What you see, for example, if you go on a live hotspot, you can see that the reward scale right now is 1. But the test you're doing shows that if you move your hotspots there, the reward scale is going to be down to 0.8. It's funny because we usually have a lot of users asking us, hey, I see on your platform that it's 0.8, but it's actually 1. And we're like, yeah, wait for it. Somebody came online in your region, it's going to go down to 0.8 sooner or later. Sorry for that. So yes, you can imagine now that if you open up intervisibility analysis also, as I said, the map gets a little bit, too much information, but it will definitely allow you that, if you want to go out of this resolution so that you don't affect the reward scaling, then whether you go here in a blue area or whether you go in a green area, it has a big difference on the earnings you're going to have with your hotspot.
Huh. Okay, so I guess that's another way to think of it, is that these colors are a proxy for your estimated earnings.
Yes, actually, that's also a question we've been getting, whether Kudzu will ever, show some type of statistics about the possible rewards you're going to have.
Sure. And
we really try to keep out of this. We've seen that, there are a lot of factors affecting your rewards in the end of the day that are completely uncontrollable from any type of simulation tool. That could be the quality of your network, whether, for example, you are on Wi-Fi or on a slow metered connection or something like that. So we do try to stay out of it. We can tell you how many hotspots you're going to see, what's your reward scale is going to be. And I don't know, Yanis, would you like to go to the, to the heuristics part?
We can actually go there like in a while. So I just wanted to say that like all these kind of features that we're presenting right now, as we discussed, like we're mainly targeting, well, our initial like business model is targeting people installing networks. So they don't really care specifically about the earnings. They actually want to maximize the coverage. They want to maximize the reach. Sure. So we show all the different components that eventually compose your reward scale, your estimated, let's say, reward like range. We can do that. It's something actually it's in the roadmap for the near future, but it's not the immediate thing we have in the mind right now, for example. And right. As Dimitris is gonna show you like in a while for the higher grade, let's say, like for like we have a bunch of algorithms actually. Not all of them are accessible on the free plan. We have a free plan, so people can actually test this out like for free, but there are also paid plans. Mm-hmm. And for the most elaborate of our customers, we also have a mechanism that allows you to estimate again position. So Dimitris can show you this particular part. So because even us, many times when we're asked to provide some consulting and provide some help in some areas and say, hey, where should I put my gateway to maximize my earnings, things like this. We want to provide these tools like to the community, want to make them available. So you don't always come to us, you don't always like call us, wait for us to be available, pay consulting fees, all these kind of things. So you can actually use the tool to provide this kind of answers. So Dimitris is going to enable a feature we recently added, which kind of runs a simulation in the system, trying to find out the best places for your gateway so you can maximize your reward scale. So
very cool.
And again, keep in mind that these are mechanics we have inherited from the Kudzu Analytics platform towards the Helium domain. We've been getting, for example, we saw that we need a lot of engineering time to answer questions to network operators, such as where is traffic, and if there's traffic in a region, or if there's saturation of the network in the region, how should I redeploy, or where should I deploy more gateways, LoRaWAN gateways, in order to solve this kind of problems. So on the first level, when we were starting with Kudzu, we were solving these problems for our network operator customers. But at the end of the day, we saw that it takes a lot of engineering time to do this. So we are running a few algorithms to do this. One of them, we just changed it into calculating the reward heuristics, the reward scaling of Helium. So you can just click the button. It's not available yet for everyone, but it's a nice, demonstration purposes. You can click the button and you can see that if you move your hotspot in this region, even if there is a live hotspot, you can just, again, pop it to draft and move your hotspot in this region, then there you are. Your reward scale is going to go back to 1.
Got it, their reward. So now, is that a function of both reward scale for that location and for estimated earnings, or that's just showing you, hey, you need to get out of that hex in order to clear it?
This is, for the time being, it's just for reward scaling. Okay. If you remember at the beginning of our conversation, we do plan to combine this with intervisibility analysis so that you can, directly find the right location that you get best reward scale and best amount of witnesses, possible witnesses.
Got it. Okay, cool. Very cool.
Great. Now, just finishing up the features, as I said, that we've said it a lot of times, this comes from the LoRaWAN world. Yep. So one of the ideas that might not be very useful for basic Helium users is that you can actually, let me just close these, the rest of the hotspots, the possible locations. There you go. The idea behind the tool is that you can actually combine different networks and see the coverage of different networks. And this is actually where things get a little bit interesting for Helium and the way that Helium has been deployed. If you take a look on this, for example, this is, let me close the reward scaling, it's gonna be a little bit clearer. This is, for example, the coverage that the Helium network is providing right now in this island. I will just move this here. Sorry for this. There you go. Oh, I forgot.
You can also go in the settings and stop actually using the focus gateway for.
Interesting. So you're probably going to show what happens when you start covering with Wi-Fi and cell and LoRa. Is that kind of where this is going?
Well, this is going towards the fact that you can see other networks here. You can
VPN or something else.
Yes, exactly. We have a VPN deployment here. Sorry for this. You can see the blue dots here. This is the TTN network.
Yep.
And you can also see, let me stop the rendering there.
Interesting. So do you guys think, or you're seeing that both, like a sensor will be able to communicate through both TTN, which stands for the Things Network. It's a funny thing, but both TTN and Helium, so that sensor can basically get more coverage. That's where you think this is going?
The latest advancements in 𝗨𝗧 so that there's already relaying messages from one network to the other. It's what we have used to refer to on 3G networks, on mobile networks as, I left my word there. What was the word? Janis, help me out on this.
Anyway, what are you looking for? So you should actually just disable the focused gateway there if you want to see the full
cover. That's fine. I was talking to the fact that if you are on a TTN network coverage and you send your message because you are a Helium device, TTN will be able sooner or later to get this message and throw it to the Helium servers.
Relay, you mean?
Yes, relaying, roaming, sorry, that was the word. Roaming already works with 𝗨𝗧, so it's very interesting to see how these different type of public networks are going to operate. Now, one thing that you can see happening here is that Helium users are trying to get as close to each other to get more witnesses, the green dots, while TTN networks are usually relying on developers who, they don't really care about the witnesses, so they do care about spreading out in the region. So that we can see have a completely different coverage of the existing TTS here than on Helium.
Yeah, so for example, incentives, right?
Exactly. If you want to deploy an application for example, tracking of buses or cars or whatever, you probably need to go for TTS that it's covered, has a much spread it out coverage in the island. However, if you want to track, for example, small devices, then you do need a lot of hotspots. So at that point, Helium is actually better for you.
Interesting. Okay, I hadn't thought about the implications of the different incentives, but it sounds like that's pretty cool if they can work together. I'm unsure of how the earnings side will work, but that's not really in the purview of this conversation. So okay,
we'll see how it's gonna go.
Yeah.
Great.
Actually, it's also interesting. Sorry, I'm not sure if you're gonna go there like another topic. I just want to summarize something related to what we just said. So in the beginning, Dimitris also mentioned this a bit. This is like one of the goals of Kudzu. So one of the reasons, like let's say the heart, business or the heart like mentality we want to have is we want to make radio uplinks, let's say, simple for the users. We want them to focus on their applications, and we don't want them to consider what happens when they send their data, where their data goes. That's why we also have like the both sides of the system, both the device and the network. So what we're trying, if specifically, if you just like check our devices, our like IoT main board that you can use, it is intentionally radio agnostic. It has multiple radios that you can use, so it can pick out the best uplink, the best route, let's say, from your place you are right now up to the cloud. And this is one, let's say, not the best example, but like one step towards actually enabling all the different networks you just mentioned before, Wi-Fi coverage, 4G coverage, all these kind of things. So you can find out how our device can reach the world. Now, our device is just like a reference, a point of like design of, let's say, good engineering or how things could work. So you can have the users, the developers not caring about this hardware and about their uplink and just like focusing on their app. But our services are actually available for other stacks too and other platforms too. So it doesn't need to be tied to hardware that we're developing. Just a side story again to link or better understand perhaps the mentality or the thinking behind all of these things in Kudzu.
You guys got to get a gateway on the north side of that island, huh? There's nothing up there.
Definitely.
While Yanis was talking, I was playing with the coverage of the two different networks. So this is the coverage of the Things network deployed on the island, and on the other side you can see that the Helium network is much more centered in this region. The North Island does have a third LoRaWAN network that we're not really allowed to show because it's for research purposes. But it's also, this side is the completely uninhabited region, so there's not a lot of sensors deployed there yet.
Right. Looks like there's a mountain right in the middle of it, though. Might be cool to put a gateway up on top of there. Just talk to those research people.
Well, yes, actually, there's some infrastructure there because a lot of the communication in these islands comes from radio signals. And yeah, it's not that easy to install things for research. You do get, you know, a lot of licenses and stuff like that, although you're in a nice environment.
Cool. Okay.
Great. I will. I don't know if you want to see something on the platform, then I can stay on the share screen session, or we can just jump back anytime.
I think that answers most of the questions I have. I mean, if I'm looking at this to kind of recap the convo, if I'm an average Helium user with, let's say, 1 to 10 gateways that I've deployed, and they're going into friends and family and maybe a couple businesses, I'd think about using this for where I would optimally deploy those 10 gateways in order to, as a Helium user, to earn the most HNT, because that's what's driving most of the growth of the network. The one thing I'd like to see is, let's say I think we talked about this earlier, for any one of these hotspots that we're seeing, can we zoom in and see that it'll tell you that you'll do better or worse for small distance moves? So typically there's not going to be a huge coverage distance if you move it 10 meters to the north or south or east or west. But have you guys seen a place where a 10 meter or 5 meter or smaller?
Plenty. Yanis, would you like to jump on that part of the demo for you know, places where we have high quality data and you can solve this out?
You mean in Thessaloniki?
Yes, Thessaloniki or Athens, where you can see that if you install your gateway on a street level, for example, actually, let's not bother you. I will give me a moment to just switch on another network that, you know, doesn't have a lot of gateways, because this is going to get a little bit slow if there are a lot of gateways there.
By the way, as the images is moving around, I'm also going to explain a feature in the platform. Like, again, if you're on the paid plan, you can actually not put them all in the Helium public network, which is visible to everybody. You can create your own private networks and you can manage them in a different way.
Okay, so I'm probably not super useful for Helium users, but probably really useful for someone who's deploying their own private network or something kind of different than Helium. Okay.
Again, this is coming back from the fact that we're covering, you know, normal LoRa deployments, and we're just like covering also like Helium deployments more specifically now.
Yeah. You guys are kind of like a wireless planning network first company, and Helium is within that range, but it's certainly not the limits of your ability.
Exactly. Okay. It's one feature on top of the of our platform.
Got it. And in the Venn diagram, Helium's a small circle that's in the middle of that bigger circle. Okay.
Yes, there you are. So what happens if you zoom in, for example, in a region that we do have higher quality data? You can see that, for example, if you install by mistake, maybe, you know, your hotspot in a street level or something like that, then you can see that your signals gets blocked a lot of time. If you move this on a rooftop, you can see that things will actually change a lot if you zoom out and get a different kind of quality of data. I don't know if that answers your questions. Usually, you know, it's kind of hard to find the exact spot because it's, you know, it's a huge city. But this is how when you're moving in, when you're closing into zooming in a lot into a city, then you can start pulling very high quality data, and it can tell you, for example, that, you know, if you move this a few meters, then you will get a different idea of how it works.
Okay, so this is more showing from what I'm seeing here is more showing that if you put it in the street, your coverage sucks, but if you get it up high, your coverage is better. That's pretty straightforward. I'm interested in, you know, as I see this, you got a couple different orange areas. I'd be curious as a hotspot placer, is like what happens when I start clicking around those orange areas, or maybe out at the edge of the red areas, and seeing where can I absolutely optimize, even within a few meters difference, a placement where it's a non-obvious thing to someone walking in the street. Right? You put someone in the street and they look around. If it's all blocked by buildings, it's pretty obvious that you go on top of the building. But it'd be pretty interesting to see on top of the building if there's a specific placement on that roof that'll be more likely to see other.
Well, actually, what happens, and we see that a lot, is that, you know, people get on the roof and they say that, yeah, I can see very far from my roof. I can see up to the sea, for example. So this is probably a good location. And what we keep trying to tell them is that, you know, it's this funny thing that you see what you see, so you think that you can see very far. If there's a small hill in front of you, you know, in a distance of like 5 kilometers, for example, then you probably, you know, your eye doesn't really even see it in a dense city environment.
Right.
So we do tell them that, yes, even though you think that this is a very good location, try to put it there because, there might be a tall building somewhere in a distance of 2 kilometers blocking, blocking your visibility a lot.
Fresnel zone, okay.
Yeah, exactly.
Just to remind something here, you can still use the intervisibility analysis, right? So if you have a few gateways around and then you're looking for the best place on your roof to put it, then intervisibility analysis can help you here. So that would be like another thing to do. Because both intervisibility analysis and coverage analysis are using the same topographical data. So if they're high resolution data, you get better accuracy on your results. That's like the idea.
Okay. Do you guys mind if I asked you, I had a client yesterday who's deploying in Senegal, in Dakar.
Okay.
He's got 10 hotspots, and I'd be super curious to see, as you guys, if you have any data on that area at all, kind of what your recommendations would be. I know mine were that he'd deploy along the coast so that all his hotspots can see each other. And I'll assume that your geography is as bad in general as my American geography. So it's West Africa, kind of right out in the tip in the middle of it. You guys might know it off the top of your head. I did. My wife used to have a business in Africa, so she knew right where it was.
Well, I was zooming out slowly to pretend that I know exactly where it is. But
yeah, you're gonna go left from here, so it's right on the coast, and you'll see.
Okay.
You go west. Yep. So there's Dakar, that kind of hook on the coast. So if we've got, let's say, in this area that we're looking at, maybe more like the left half of the screen, if you had 10 hotspots to deploy, and they're helium hotspots, so you want them to earn maximally, maybe you're not so concerned about providing perfect coverage for sensors. Yeah. Where would you guys put them?
Well, there you are. I have no idea about the geography already, right?
Yeah.
So I would just add my first, let's say, 3 meters tall hotspot. So that's, put a hotspot on 3 meters above your roof or something like that. And then start my coverage analysis. This might take a little bit more time because I've never done it on Senegal. So this is going to be downloading a few more data than usually. Okay. There you are. Oh, thank you very much, Nick. You just moved to a region where there's no data.
I mean, this is, I didn't do it on purpose for sure. But
no,
this
that's fine.
That's fine. We all kind of have to figure out and deal with is if you're sitting here and, I'll tell you what I found out in talking to him and doing some research about the place is that this area is pretty flat, but in kind of around that area where you've got your current gateway, there's lots and lots of 4-story buildings. So a really challenging environment for any kind of wireless network because there's so many obstacles and there's kind of the deep canyons that the streets make.
That's nice. That's very interesting. Well, you did get into this, there's no data right now there. Right. So I'd be happy to do this again on a later time.
Yeah. I mean, we can try to look for another place. So if
you can actually, just throw us another place and we can figure out what's going on.
Where there's more likely to be coverage. Let's cruise up to Bar Harbor, Maine. So it's in the U.S., so there should be reasonable data. And then it'll be up in the northeast side of America, up on the East Coast, way up high. So
somewhere there, Maine, right?
Yep. We're getting close. Yep. So you can see Bar Harbor right there.
Okay, great, perfect. Let's. I guess there's gonna be already helium hotspots there, right?
There might be a couple. Yeah. I mean, this is a pretty rural area, very densely forested. So probably another challenging environment. I think that's one of the funny things is most people aren't used to looking at environments in the sense of how well will it support a wireless deployment there.
Okay, let me try to throw one there. It's somewhere there, right?
I think a general area, yeah. Nice.
Okay, so just move it there. Do you mind if I zoom in, at that level, for example?
Go for it, yeah. No, I'm very curious to see how you guys would analyze a new spot because I think that'll be really useful for any customer who might be in a newer area.
Actually, yes, that's fine because sometimes in these demos and we relax, we're talking about a lot of stuff and people get a little bit lost. Let's see. This is gonna download the data from Bar Harbor. I hope you don't get into the same situation that there's no data there yet.
Fingers crossed, right?
Because then, I think that you are doing this on purpose in the end of the day.
No, it's fun. I mean, I thought of a place where there's a fair amount of water and lots of islands. So similar kind of topography-wise to what we saw in Greece, but very different climate for sure.
Okay, there you are. So what I would do, I would just, throw one draft gateway so that I will start understanding a little bit of the geography. Keep in mind, I have no idea. Usually when people want to deploy networks there, they do have a rough idea about what's going on. So from the first view, what I see is that, probably there's some type of hill here. I'm sitting on top. So usually, if I move to that direction, probably I will be getting a little bit more coverage. And as I said earlier, coverage analysis is mostly used by our users to, figure out what's the geography in the region.
Yeah. So it brings up a super important point. And this works on anything, whether you're looking at Hotspot.rf or Helium.Vision or Kudzu or anything, is that when you run these radio sims, it really throws the topography into relief. And so it makes it a lot easier to see where the hills and ridges and valleys and mountains are. It's a cool thing to do.
Yeah, I am having some network issues apparently.
Okay.
Nice.
Cool. So the kind of general flow, though, is that you throw down one draft gateway and you just get an idea of the topography from that gateway. And then you start placing a couple other gateways. And basically, you're filling in your understanding of that area. And then probably for Helium, you're really looking for the high points and putting it on the high points. And then maybe tweaking it for coverage down inside a town, and also the gateway that's in the town to be able to see the high points. That's kind of how you guys would do it?
Well, I'm trying again once more. Sorry for that. While we're talking, but yes, the idea is that first you just throw a draft gateway there so that you get some idea about the topography of the region. Let me just put
while Dimitris is setting up the environment, just let me clarify something that usually some kind of information about the area. For example, where the hills, where where the harbor, so usually where to start this analysis from. But the idea from this point onwards is exactly as Dimitris says. So you just try to analyze the coverage from this area, and then you keep adding more and more gateways depending on the coverage you will achieve in this particular place.
Great. So there you are. There's a spot that it looks like we are on kind of, on the top of a hill or something like that. What I would do next is, go there and install a few of those. Keep in mind that you don't really need to be very strict about the height and antenna gain, because, you can change this anytime, of course. So there you are, a third one, maybe, a fourth one, and start getting the idea. So we're still on coverage analysis so that we see that, we have started covering the area. Or maybe if you want, we'll just throw another one somewhere, on the opposite side.
Yep.
You usually try to cover the blind spots, right? You just try to find out first what's going to be the place. You
guys are totally thinking like network operators, not like Helium deployers.
I'm pretty happy that this is clear. Yes, exactly. So by deploying, like 4 of them, let's say that this is my friend's house and my house and stuff like that, the next step would be to go to your Intervisibility analysis and start seeing, are there any spots in this deployment that, we start seeing each other, for example? For example, this one, it looks like, if you focus on this one, it doesn't have any possible witnesses, but there are regions very close around that you will start getting some witnesses.
Super valuable. Okay, so that's where it will make a difference to say, like, hey, if you go 100 meters this way, maybe it's up a hill.
Exactly. And then you will focus to the next one, see, oh, okay, there you are. This one has 1 witness. We're not very good, but at least we do have some.
And when for example, you can start tuning, right? So I see like a red area a bit far behind. So you can actually try.
I'm gonna get there. So for example, you have your 4 gateways there. You see that we're not doing very well. We only have 1 witness in the region. That's the only one I didn't test, right? Let's run this one too. There you are. We don't have many witnesses there. So you can actually go there and start fine-tuning your deployment. You might have, a very large house. I don't know.
Sure. And then do you, right. Are you able to see the RSSI on those lines, or like, how are you, because I think you said that doesn't look very good. How are you telling that was a good deployment or not?
Well, if you remember, we are in the visibility analysis now. So with having deployed like 4 hotspots there, we are coloring the map based on how many witnesses there are. So red areas is where you're going to have 3 witnesses. If I move this one here, for example, oh, sorry, that's not the focus one, that's another. Sorry for that. Let's focus on this one. So this is our deployment. This is where we have available solutions. If I go in a red spot, then I know that, this place here gives you 3 witnesses maximum visibility.
Okay, super cool.
Yeah.
So you kind of start by the network operator point of view, and then you calibrate it to maximize your Helium earnings. And the result is like a happy Helium client and a very well-covered network coverage. So practically, as we mentioned in the beginning, we're making our Helium customers, the Helium users, become a proper network operator. So they maximize both the yield for the Helium community and for their pockets.
Fingers crossed. I think most people are going to choose their pockets. I mean, I think it's a rad thing to deploy the network. And really, if we look at the long term where Helium's going, is they're going to continue to incentivize better and better coverage and not so much better and better kind of inter-gateway deployments. But for right now, that's where it sits. And this looks like a pretty cool tool for being able to optimize either or both. So
yeah, you can see that for while you were talking, I was doing some very small micromanaging there. And you can focus to each different one, and you see that all of them have 3 witnesses already.
Yep.
What you said is true. However, Helium will be changing things around. This is one of the reasons why we have added all these kind of options. For example, what is a valid witness is going to change in the future. I think it's HIP 22, right?
Yep. Yeah, PSG, I think V11.
So you can change, for example, you can go there. We will change the default values. I don't know if it's going to be like 110 or something. We're going to be very easily analyzing this from that point of view.
Yep.
Actually, this was us answering a question you asked a bit earlier. Like, how would you know that this is the best place to put them? What's going to be the RSSI? You said, like, the best network quality. What the 𝗵 is tuning here is actually your desired link budget, and say, hey, between every gateway on the map, between every 2 points on the map, I want to have at least, I don't know what he's using right now, minus 50 decibels.
Yes, I want to a little bit on the extreme side so that you can see links getting cut down. So if tomorrow Helium decides that a valid witness is a witness that has like 50 dB RSSI, minus 50 dB RSSI, then you can just switch to 50 and see that, okay, this is not going to be valid anymore.
Right.
So
oh, interesting. Cool. So I guess the other thing I'm seeing here is that you guys, and this is probably a business decision on your end, is that some of these tools are really useful, but really require an understanding of how the network works in order to get the max value out of them, right? This is not yet a place where you can say like, hey, I've got 10 hotspots to deploy in Bar Harbor, like tell me where to put them. It does require some kind of work and knowledge of both the system and the physics of radio to place them. But man, this does make it easy for even people like me who don't know very much about this to probably do a pretty good job. So
I'm really glad you're saying that. This was the idea actually, and we're gonna keep moving towards this idea that Helium, what Helium did is, the people's network, people are not supposed to know about RF, but they are the network operators right now.
Yeah.
So they should have as less knowledge of this kind of stuff as as they need. And what we try to do is this, you see a red region, go there, go put your hotspot there. It's going to have the maximum witnesses.
Yeah.
And if you remember, by the way, before we went to explaining all the technical details, you can already see things in the network, so in the platform. So if you were a bit more, let's say, tech savvy or like radio savvy, you might want to expand into the details and tune them to your needs. But the platform already gives you like a very good like overview for 80% of the users, so they can just like start trying things out, let's say.
Yeah.
It's not going to guide you and tell you, hey, here is a spot, like mark an X and say put it here. But it will give you the tools and the gradients so you can actually find out the best place where you can put your gateway in this particular place.
Cool.
Yeah.
Very cool, guys. I'm excited. This is it's another neat tool to add to the Helium network. So good to see.
And since you talked about business decision, another hard part of developing this was that, as I said earlier, the network is going to be changing. So RF analysis is going to be something that we think, and we believe that people should have, always available. And this is why we went towards these billing plans where you can have a subscription and do as many simulations as you want. That's not a problem for us.
Sure.
And the second thing is that, a bunch of features that is coming on in the next weeks, months, which is gonna start merging what Kudzu Analytics is actually doing, which is analytics on networks, with all this type of information that people are interested. So you will have some kind of dashboard where you will be able to monitor, your earnings, monitor the quality of your of your witnesses, or changes in the witnessing and stuff like that.
Sure. Cool. Very cool.
And keep in mind that this is like the top of the berg, let's say, of Kudzu analytics. This is just like a focus on Helium community. Yep. As Dimitris mentioned, the main core functionality of this platform is radio analytics. Now, we're only focusing on the map part, but you can actually do much more with this particular platform. I'm not really sure it's like very interesting for the Helium community right now, but we're actually in the process of including all these new cool features like into the platform. There's also like a heap suggestion we started, which is going to enable like to whoever's interested, and it also includes us, to provide much more elaborate information about your current network. So this is more useful once you've deployed your network, to make sure that it will stay reliable and yield as much as it can for the day 0 onwards. Because we discussed about the planning, but a really important thing is the day 2 operation. So after you've done your deployment, what do you manage? And that's actually something many people not really consider when they're planning their deployment. Right. But we already have the answers for them too.
Cool. Great. Cool. Dig it, fellas. So let's see. Website is just kudzu.com.
.gr.
Okay. .gr. All right. Cool. I will. I'll put a link up to that and make sure that it's easy to do. I think I'll probably go through and make sure I write out some kind of instructional piece and run it by you guys and make sure it's intelligible. But I think that's a super cool tool, and thank you guys for taking the time to share it with me. I appreciate it.
Thank you very much. Welcome. It was nice being around.